The next section, 7.3, is finding the volume by taking cylindrical shells. And so we've got a little bit different formula here because we have the different formula for the volume of a cylinder. You're going to see a couple extra things here. You're going to see a 2 pi, and you're going to see a y if it's rotated about the x-axis. And then if it's rotated about the y-axis, you're going to see a 2 pi and an x. So it'll make sense with what the equation looks like. So here's the example. Use cylindrical shells to find the volume of the solid generated when the region enclosed by y equals x equals 1, and x equals 4 is revolved about the y-axis. So if it's revolved about the y-axis, my equation needs to be y equals. Okay, so we can find this volume. We can just use the letter V for volume. I've got my 2 pi, and our bounds are from 1 to 4. Now, the reason why you see the 2 pi already on the outside is just because it's a constant, so we can move any constant to the front. So we do need to put an x, and then the function itself is the square root of x. So to simplify here, I first recommend you change that to an exponent. So I can rewrite this as x times x to the 1/2 power. So square root of x, x to the 1/2, same thing. So what that lets me do is I can simplify this by simply adding my exponents. So what we're going to be integrating is really x to the 3/2 dx. So let's kind of go over how we would find the integral of this because our exponent is a fraction. So I'm just going to leave that 2 pi in front the whole time. So I'm going to be doing just the straight shortcut to the integral for a polynomial. It's 1 over the exponent, which is 3/2 plus 1, x to the 3/2 plus 1. So to simplify that, let's come over here. So 3/2 plus 1 is 5/2. So 1 over 5/2 is 2/5. X to the 5/2. And we are plugging in 4 and then 1, and I'm honestly going to save the 2 pi for the very end. So first I'm plugging in a 4. And I'm getting 64/5. And then if you plug in a 1 here, that just becomes 2/5. So 64/5 minus 2/5 is 2 pi times 62/5. So here's what we can do. Just do 2 times 62/5. Okay, and then our final volume is going to be 124/5 pi, or if you'd like the decimal version, that is also okay.